Hi, welcome back. We're going to do lesson 3-6 today over linear pairs and vertical angles. So first we're going to start with a definition, opposite rays. So it's just simply a line. It's a line. um, so when you have a line, here's your point. So you have ray, let's say A, B, and the opposite ray would go in the opposite direction from A, and that would be ray AC. So opposite rays would be rays A, B, and AC. And guys, it just looks like a line. Now, what you need to know is that when you have our next definition, a linear pair, it's two angles that form a line. So don't make it more difficult than what it is. My definition just is two adjacent angles that equal 180 degrees. Okay, so don't overcomplicate it. It's very similar to supplementary angles, but if you remember back to the previous lesson, supplementary angles could be adjacent or non-adjacent. But with linear pair angles, we now have a picture that has to look something like this. You have to have two angles that share a side and share a vertex. Okay, so the book definition is two angles that have a common side and their other two sides are opposite rays. So, it fits both definitions. And so later, if you see a picture where it's like, classify these, this picture here, this picture here is never a linear pair. That is only supplementary. This picture here could be a linear pair and it could be supplementary, okay? Just to be very clear. Now, Theorem 5 helps clear all this up. It says the angles in a linear pair are supplementary. So again, if you're trying to prove something, like, you have a proof and you're trying to prove that it is a linear pair is supplementary, you would just refer back to Theorem 5 that all linear pairs are supplementary. All right, vertical angles. Now, vertical angles, we use these all year long. Well, we use everything all year long. Who am I kidding? I'll read you the book definition and then my definitions in italics. This is two angles with the side of one angle are opposite rays to the sides of the other. And I think that's really confusing. My definition is non-adjacent angles formed by intersecting lines. So first of all, you have to understand what adjacent means. Adjacent means they're next to, they share a side and a vertex. So adjacent would be 2 and 3. Non-adjacent would be 2 and 4 or 1 and 3. So for this picture, you have intersecting lines, yes. So my vertical angles are angles 1 and 3 and angles 2 and 4. Now, the interesting thing is every time you have vertical angles, they're equal. So let's extend this. I know angle 1 is equal to angle 3, and I know angle 2 is equal to angle 4. Now, something you'll never be able to unsee. When you get a pizza and they cut it, hopefully they cut it in a way where it all intersects in the middle, you have numerous vertical angles. So if you want a piece that's the exact same size as your friend's, if you guys take the vertical angle pieces, then both of you have the exact same size piece because those were formed by intersecting cuts. Interesting, right? You didn't know I could run pizza for you. All right, so we're going to do a problem off the Core 40 homework, again, which is, the kind of stuff they put on SATs very, very often. So we have two angles, ABC and EBF, and let's see, they are vertical angles. See, are a pair of vertical angles. Okay, so the measure of the first angle is 3x plus 8, and the measurement of the second angle is 2x plus 48. All right, so our goal is to find each measurement of ABC and EBF. Okay, so I'm a very visual person, and I hope you could read my scratchy handwriting. I have to draw this out. So when you do this, remember the middle letter's the vertex. So A, the middle one's B, C, and then its vertical angle would be this way, E, B, F. They're a pair of vertical angles, so we know these are congruent. So ABC is 3x plus 8, and EBF down here in the bottom is 2x plus 48. And we know because of the theorem we were just taught, let's reference it by number, theorem 6, you will use this a lot, the two are equal. All right, so let's set them equal. So my personal method of doing algebra is if there's variables on both sides, I move the smaller one over so my variable stays positive. I don't like negative variables personally. So x is 40. I'm not finished because it doesn't even really say find x. It just says find the measures. So let's find the measures. The measurement of angle ABC, let's plug it in. 3 times 40 plus 8. So it's 120 plus 8, which is 128. Now, if we do it correctly, the other one should have the same answer. So EBF, this is an angle, 2 times 40 plus 48. So 80 plus 48 is 128. And these are degrees. And the answers are the same. So I did them correctly. So that's it, guys. Let me know if you have any questions, and I'll see you later. Thanks.